All right, number 7, we want to consider this function. We want to identify the general shape. Okay, so notice this. We're looking at this x to the 5th. This is the indicator of what's going on. So this graph generally looks like this. X to the 5th is something similar to this. Okay. But because of the negative out front, okay, this negative is going to flip it across the x-axis. It's going to make all my y values negative. So this part right here is now going to be coming down, and then this part that was going down is now going to be coming up. So what we actually get, so it's really the same shape, same general shape, but it's just going to be flipped going the other way. So something similar to that. So because of its negative, so instead of going up from left to right, it's going to be going down, and this is the only one that kind of really matches that shape, and that's because of the negative out front. All right, now we have a part 2 here. So now part 2 wants you to find 2 points on the graph of this function that fit in the 10 by 10 window. All right, so we're going to plug in an x value and find a y value. The best to do, I don't know why, but I think I've tried 0, 0 and it doesn't take 0, 0. Like even if you plug in, so let me just show you for example. So this is tx, they're using a function of x, t as a function of x is equal to negative 3 over 5x to the 5th. Okay, so if I were to plug in a 0, so I said x equals 0, so t of 0, that would give me a negative 3 over 5 times 0 to the 5th. Okay, so 0 to any power is 0, and then 0 times any number is 0. So we would get t of 0 equals 0. So you get the order pair x is 0, y is 0. That's the order pair that we get. But for some reason it doesn't take 0, 0, or at least it didn't, and I'll show you that. So I'm going to plug in 0, 0 for 1 point. And then the next easiest thing to do is just to plug in a 1. Okay, so if I say t of 1, I'm going to plug a 1 in. I'm going to get a negative 3 over 5. And then I will plug in a 1 here to the 5th power. So 1 to any power is just 1 times 1 that many times. So this is just 1, and 1 times any number is itself. So you get the ordered pair 1 and then negative 3 over 5. Okay, so I'm going to do 1 and negative 3 over 5. So it probably will tell me incorrect, even though this is correct. Negative 3 over 5. And while I'm here, I'm also going to show you graphically. So you can graph this with your graphing calculator. I'm going to turn this on. Go to y equal, clear out what I have here. And I'm just going to do negative, and then in parentheses, I'm going to put the fraction. 3 divided by 5. And then I'm going to do x raised to the 5th. Okay, so I'm going to go second table to see the table of values. Now, notice the first one you see is 0, 0. And then when you have 1, you get negative 0.6. So if you do negative 3 divided by 5, you will get 0.6. Let me do second quit and just do negative 3 divided by 5. I like to leave it in fraction form, so that's the same. So I'm going to check it, but I believe it was not accepting 0 when I did the practice before. So just to show you, it says that's incorrect. So we're going to do a similar, it's going to be a different function. But what I recommend that you do, instead of doing 0, which is really easy, and I'm not sure why it doesn't take 0, I would just recommend doing positive 1 and negative 1. Both of those are really easy to plug in. Okay, so just in case you run into that issue. So I'm going to do the same thing with this different function that they've given me now. S of x is equal to negative 7 over 5 x to the third. Okay, so I'm going to plug in 1. So I'm just going to plug in 1 for x. So again, 1 to the third power is just 1. 1 times any number is itself. So this negative 7 over 5, I get the ordered pair 1, negative 7 over 5. Okay, and then I'm going to do that with negative 1. Those are really easy to work with, 1 and negative 1. Negative 7 over 5, and then we have negative 1 to the third. So here we're doing negative 1 times negative 1 times negative 1. Negative times a negative is a positive 1, and then a positive 1 times negative 1 goes right back to negative 1. So I end up with negative 7 over 5 times negative 1. And then a negative times a negative is a positive, so I get the ordered pair negative 1, and this becomes a positive 7 over 5. Okay. So that would be better to use. It should accept it this time. So 1, and then we're going to do negative 7 over 5, and then we're going to do a negative 1, and then positive 7 over 5. Okay, and then now it accepts. So again, I'm not sure why it doesn't take 0, 0. It is definitely on the graph, but for some reason, I guess they want different points other than 0, 0. And I don't think it says that. It just says within the 10 by 10 grid. Okay, so no indication why that doesn't work. Okay, number 8. We're going to do that one as well here. We want to identify the shape of this graph. So we have the indication of like 1 over x to the third. Okay, it's an odd. So remember, those odd go left to right in that corner. And so that's the only one that matches. It's positive, so it should go left to right. That's what I think about. So this one is the one we want. And then we want to graph again. So again, I'm going to use positive 1 and negative 1. Again, really easy to plug in ones. So we have w as a function of x is 9 over 2x to the third. All right, so I'm going to plug in a 1. 9 over 2, 1 to the third. So this is just 1. 1 times 2 is 1, so I just get 9 over 2. So I get the ordered pair 1 and 9 over 2. And then if we plug in a negative 1, negative 1 to the third. Negative 1 to the third is a negative 1, so you get 9 over 2 times negative 1, and that would end up giving you the ordered pair 1 and a negative 9 over 2. So all that 1 is doing is changing the sign. Okay, so whatever you get for positive, you're going to get the opposite for negative. That helps. So 1 and then 9 over 2. And then negative 1. I don't know, I didn't put the negative here. Gotta be careful there. I just wrote down 1. Negative 1 and negative 9 over 2.